Okay, so now let's look at stress concentrations for a shaft. And we're going to see that things are fairly similar to what we did with stress concentrations with axial loaded bars. And so just remember our maximum shear stress is going to be TC over J. So where can this stuff be applied? Where do we have to worry about stress concentrations in a spinning shaft? And so we got a couple different ways. Stress concentrations will occur in shafts at points of sudden cross-sectional changes. So you have things like couplings here. We will end up concentrating forces right here along the smaller diameter of the shaft. We will do it at keyways. So when we have a keyway cut into it here, we'll end up concentrating right into that area there, and at shoulder fillets. So once again, we'll end up concentrating right there on the small side. So a lot of these, especially with shafts, are going to be calculated on the smaller diameter because that is where our stress is really going to concentrate. So something to think about: the more severe the stress change, the more severe the stress concentration will be. Now, much like when dealing with the stress concentrations in flat plates, it's not necessary to know the exact shear stress distribution across the entire section, because obviously, as I start here at the fillet and work to the other side, I'm going to have a varying degree of change in that shear stress. But all that I'm really going to care about is what is the maximum concentration. And the reason that I only care about the maximum concentration is that's where it's going to break. The one nice thing about strength of materials is we're usually just looking for one number, and that's going to be the biggest number that we can do. So how do we end up calculating this out? Same way that we did with flat plates. We sit here and we introduce a stress concentration factor K. And so as I'm dealing with a shear stress equation that's concentrated, it's tau max is equal to K Tc over J. Just like we had when we did with normal stress. Normal stress is just going to be K times P over A. We're just looking at that stress concentration factor. How do we calculate out that stress concentration factor? Well, we go and we look at tables. And so here's one out of the book, and this is showing how to deal with a fillet. And we look at the picture and we do whatever it says. So we have lines of big D over little d. Big D is the larger shaft, little d is the smaller. I have R over little d. That's the radius of the fillet times the diameter of the smaller shaft, and then what the concentration factor is. And so once again, we're going to be calculating a lot of this based on the smaller shaft is where we're going to be concentrating these things. So in ductile materials for a static shaft, stress concentrations are really not something you're going to have to worry about much as long as everything's below the yield strength. We really need to be concerned with brittle materials, and as we talked about with our fatigue loading, our ductile materials can work themselves into becoming a brittle material. But we have to worry about that because once that stress concentration hits, things break, and generally bad things happen when we do that. So once again, should be pretty simple because it's the same thing that we did with axial loading. And that's all there is to say about that topic.